principle. Hund's rule. Electron configuration. So basically, atoms have a nucleus, right? Made of protons and neutrons, right? And the radius of that is 10 to the power of minus 13. But the radius of a whole atom is 10 to the power of minus 10. Why is it so much bigger? Because we have the electrons that are all around the place. But they're not placed randomly. I mean, technically, we can never know where they are and stuff, but okay, so electrons are found in orbitals. Now it's gonna be like confusing. I was so confused at the start. But orbitals, right? And these orbitals are called levels. And levels have sublevels. And sublevels have orbitals. Yeah, but I'm excited that I understood it. So, okay, so basically, right? One level has some sublevels, right? And each level 1 has only one sublevel, the S. Level 2 has two sublevels, the S and the P. And level 3 has three sublevels, the S, the P, and the D. And level 4 and level 4 has four sublevels, the S, the P, the D, and the F. I'm such a child. Okay, so and each sublevel is made of orbits. I understand it's weird, but like you have the principal orbits, or like the main orbits, the big orbits, however you want to call them, and then the tiny little orbits within the orbits, right? So level S has one orbit, level P has three orbits, and sublevel P has three orbits, and sublevel D has 5 orbits. In each orbit, you can have two electrons that have an opposite spin, so one goes that way, the other one goes that way, right? And we have Hund's rule that says that first you need to fill the orbits of the sublevels with the electron that goes the same way. So like, okay, you have these 3 orbits, right? And in these 3 orbits, you have, if they're filled, you have one electron that goes this way, one that goes the other way, pom-pom and pom-pom, right? But first thing first, you need to fill these 3 orbits with electrons that will go like the same way, like if we're talking about the P sublevel. And then, after that, you have like these 3 that go this way, and then one that goes that way, then these 3 that go this way, and 2 that go that way, and 3 that go this way, and 3 that go the opposite way. And then we have Aufbau's principle that says that you first fill the shells with less energy. And that is why we have the, 1 is 1, 1 is 2, 2 is 1, 2 is 2, to P1, to P2, to P3, to P4, to P5, to P6, and stuff like that. And then we have the 2 transition metals irregularities, which both focus on the fact that when you can fill the orbitals of the d block elements, either half fill them, either fully fill them, then you go for that, taking away from the 4s. So like, hear me out, right? So you have like, I need the periodic table. So the two exceptions are chromium and copper, right? So with the normal Aufbau, like electron configuration, you would write AR in brackets. Oh yeah, because, okay, since everyone's lazy in this world, instead of writing the complete configuration of like this, oh, you can see it, this guy, right? You just write KR in brackets, in quadratic brackets, and then you just write 5s1, 5s2, and so on. But for the B, I don't think we go that far back. But yeah, what was I saying? Yes, so you write AR in quadratic brackets, and then instead of writing for S1, for S2, 3D1, 3D2, 3D3, and 3D4, you write 4s1 and 3d5, because, you know, from the 4 to the 5 there is only like that one electron, and then it's like no one cares about the 4s. I understood, like when like the deep block element is just takes priority, so they take one electron from the 4s. And same goes with copper. So instead of writing 4s1, 4s2, 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, you write 4s2 and then all that, no, you write 4s1 and then 3d10. Then there was something else. Oh, yes. Then we can see, like on a scale, that, like, it's changing a bit topic, I forgot about that kind of, that the 3D orbitals have more energy than the 4s orbitals. And following Aufbau's principle, we fill first the orbitals with the less energy, right? And that is why we go, after the 3p, we have the 4s and then the 3d. And yeah, and that's also the reason why sometimes people say that Zorro, not on the table. The third orbitals have 8 electrons sometimes, and sometimes they have 18 electrons. Technically they have 18, but since the 4s comes before the 3d, then they have 8, but then with the 3d they have 18, you see. Life do be like that sometimes.